Our next speaker, Mr. Basil Ayass, Education Sector Lead at Google Cloud, speaking on today's topic, how to advance your research with cloud computing and Google. Over to you, Basil.
Thank you so much, Melvin, and thanks for the invite. First, a big hands of applause for everybody that is still powered on and have stayed on till now. It's really late afternoon here in Oman and in the Middle East, so I just wanted to thank you for that. I have 15 minutes, and I promised Melvin to try to bring us back to time and back to the agenda. I will finish in less than 15 minutes. So my name is Basil Ayass. I lead the education and research team here at Google Cloud. And we work very closely with research institutes, universities, and NRENs across the Middle East, Turkey, and Africa region. Today, to be honest, I just have 4 main points I want to quickly cover from a Google Cloud perspective. First, why cloud computing? What does that have to do with research and high performance computing? And then really to focus a bit more on how cloud solutions are different. Different than what we're all used to, different to what we use today. And earlier in the morning, we heard from Ankabut, we also heard from NYU, we heard from Omren. Everybody is very, very proud of their high performance computing capabilities when it comes to research. And today, no matter what research area you're in, whether it's biology or genomics or computation or AI, compute plays a critical role. So there's the top 500. The top 500 list, sits there and looks at, what are the most powerful HPCs around the world. 10 years ago, the most powerful one was at Los Alamos in the US. And guess what? 3 petabytes of data was the capacity, and it had a 55 gigabit per second throughput rate. 10 years later, we've moved from 3 to 250 petabytes. We've moved from 55 gigabit to 2.5 terabit, which is 2,500 gigabits. So look at the 45x and the 83x increase in just 10 years. Basically, to have a multi-million-dollar investment on-prem no longer makes sense, because within a year or 2, you will be dealing with outdated technology. Technology is moving so fast. In 10 years, you're talking about 83x. Does any researcher want to use 5-year-old technology, 3-year-old technology that's running, 50%, 30%, 20% of the latest and greatest? This is really one of the largest reasons why we see research institutes move to cloud, because they want access to the latest and greatest in technology, and that technology continues to be updated. Another reason is the reproducibility of results. And this is a major issue that we struggle with in the industry. Today, an estimate of 50% of published studies, even those in top-tier academic journals, cannot be reproduced. Think about that. Why can't they be reproduced? Because everybody's using their own custom-made solutions and computational and benchmarks and tweaks to the algorithms. And therefore, 30% of the budget research is wasted. So today already we see leading institutes like NIH and NSF that are requiring now that your research should be done in containers, so those containers can be moved and shared amongst researchers around the globe in your NRENs, in your national networks around the region, so other researchers can reproduce and peer review your research. And that is great, because today we're seeing that Kubernetes is running in 45% of container environments around the world. And that is a 10% increase year on year. So now that we said, okay, why cloud computing? Because it gives you the latest access, it gives you scale, and gives you reproducibility. Now, how is Google Cloud different? The idea is that with Google, today we are a world leader, and we're very used to offering services that can scale. We have 9 services today with over 1 billion users each. Those services are all powered by cloud. It is impossible, I'm going to repeat, it is impossible to reach the level of performance and scale that is required to support a billion users if you're not running on cloud. Cloud breaks the barriers, breaks the limits, and gives you unbelievable uptime, scale, and reliability while maintaining security. So the Google Cloud difference is that, we're here to meet you where you are. We don't try to say, hey, you want to work with us? You got to adopt our standards. We're actually very flexible. We like to partner with research and universities, and we will craft a fine-tuned, personalized migration journey that lets you run what you want, where you want it, and how you want it. So when I say what you want, this can be Linux, this can be Windows, this can be any flavor of operating system. And we have a long list of operating systems that we support. It can be NVIDIA GPUs. It can be Google manufactured tensor processing units for your machine learning workloads. When we say where you want it, we offer solutions that run on-premise in your data center. We offer solutions that run in the edge with service providers in country, in region, and we also offer solutions that run on the global Google network. And by the way, we have a fiber connectivity straight into Muscat in Oman, as well as one in Fujairah, and we're building many more as we expand what we have already publicly announced. Google Cloud, data regions, and our network is going to be expanding into Qatar and Saudi Arabia in the next few years. So we've got Qatar, Saudi Arabia, Oman, and UAE already covered with fiber of the global Google network. You can get single-digit millisecond latencies straight in because we have those points of presence in your country to enable you to run at unbelievable speeds and how you want it. So why are we seeing universities, NRENs, research institutes move to cloud? 4 main reasons: flexible compute options. Today, if you haven't heard, there's a huge worldwide shortage of GPUs. If you want to buy a GPU, good luck. I know a university that has placed an order for the NVIDIA A100 GPUs back in January. They paid and ordered. They finished the procurement process, order is out in January. They still don't have them, and they're expected to come in August. Hopefully, they will come in August. So it's taking 8 months to be able to get the latest and greatest GPUs from NVIDIA because of the supply constraints. Well, guess what? Google Cloud already has those running and ready for you to utilize. That's just one example. Secure by design. You don't have to worry about the security. You don't have to worry about ransomware. You don't have to worry about losing your data. It is by default secure. And then we are committed to open source. So we really give the customer the freedom to choose where to deploy and what. Avoid, you're not happy with the service, you move the next day. And fourth, and but not least, is really the access to the latest technology. So I already mentioned NVIDIA A100 CPUs. We just announced the V5 of the TPUs, doubling the throughput and the teraflops of the TPUs once again. And of course, we offer the latest from Intel and AMD from a CPU perspective. So today, to do research on-prem, you're going to have to wait more. You're going to have to deal with downtime and maintenance windows. You're going to have a one size fits all, and it's probably going to be aging after the first 6 or 1 year of its lifetime. It's probably going to be already outdated. When you move to the cloud with Google, no wait times, no downtime. You get access to unique hardware tailor-built to run your HPC platform and workloads and research workloads, and you get access to world-leading AI capabilities, and that is really interesting. So today, researchers using cloud are 2 times faster than researchers using on-premise, and every 12 months. So every 12 months, they get 2 times faster. So of course, we work with a lot of our partners across the board, whether that is the Broad Institute, ANSYS, Altair, Cadence. We work with SI partners in Deloitte and Atos, and Burwood. We also work with a lot of infrastructure. Slurm is very popular in the Middle East. We integrate with Slurm. We offer a hybrid solution on Slurm. And we also integrate with on-premise hardware vendors. So Dell EMC, NetApp, your Lustre. You can keep some of the data on-prem if you prefer, and we can integrate with that straight on, especially with DDN. It's very popular in research and in oil and gas in the Middle East. So now that we've covered the why and the how, let me give you some examples, and this is my favorite part, just an example of what can be done. So Broad Institute, for example, they work with genomic data, and they have today 45 petabytes of data on Google Cloud. Just imagine that. Does your on-premise solution support 45 petabytes of data? What is your quota as a researcher with on-prem solutions? And Broad is growing half a petabyte per month. And that is an immense amount of data. A petabyte, just to remind you, is 1,000 terabytes. 1,000 terabytes, 1,000,000 gigabytes, 500,000 gigabytes a month is the growth rate at Broad. And the great thing is they are now reaching insights. It used to take them 8 to 10 days. With the latest technology that is available on Google Cloud, they can do this within 24 hours. So they were able to drop. So they're doing it faster. They're doing it at an unparalleled scale, and they're doing it cheaper. Usually, cheaper and faster can't intermix in one sentence. You either get faster and more expensive or slower and cheaper. But today, with the cloud dynamics that are available, you can get cheaper and faster. So they were able to reduce their genome processing from $45 to $5, and that's a 9x reduction. That is unbelievable. This is another example I love. Andrew Sutherland, the professor at MIT, he says, and I quote, "It changes your whole outlook on research when you can ask a question and get an answer in hours rather than months. You ask different questions." I love that. I love that. It really opens up your mind because we've always been constrained with what's possible. But when what's possible becomes so much larger, wow, you start asking 10x questions. You start aiming for much larger research capabilities. You become a lot more ambitious with what you're trying to achieve. 2 million CPU cores. Just think of that. Professor Sutherland is running research on 32,000 instances, each one with 64 cores. So he can run research on 2 million cores. Who has 2 million cores on-prem? I can count them with the fingers of one hand. Clemson University is another great one, another 2 million vCPUs, 2 million cores running, and they're analyzing 2 million hours of video, 200 terabytes of storage with 128 gigabytes, not gigabits, gigabytes of I/O throughput. Unbelievable Slurm. CERN, I'm sure you're all familiar with. CERN in Europe is complementing their on-premise capability because they need the bursts. At some hours in the day, in some days of the week, their capacity to run at 150,000 cores on-prem is not enough. So what they do is that they burst to the cloud. And this is showing you that today, at some stages, Google Cloud is offering an additional 160,000 cores of CPU raw power to complement what CERN has on-premise. And that just blows my mind. We're actually doubling their throughput for a few hours every day with on-prem. And this makes financial sense. Instead of them doubling the throughput of their on-prem HPC, like we heard so many NRENs hope to do and universities hope to do in the region, hey, keep what you've got and burst out to the cloud. And that gives you the best of both worlds. So with that, I just want to end with how to get started. So I'm going to make an offer because we have this ongoing debate within Google when we're doing these digital events. And are people listening? Do they care? So I'm going to make an offer. This is an unparalleled offer. Anybody that is listening to me right now can email me on my email right on the screen. And I will personally walk you through, and give you a gift of $5,000 of GCP credits. No strings attached. You're a researcher, you got a research project, email me right now, visit our booth, drop me an email. You can WhatsApp me off the booth. Melwin has this amazing platform. WP Summits has built it for us, but nobody's using it. Go to the Google Cloud booth and just click on that WhatsApp button, and a WhatsApp will be delivered to my phone. And I will make sure to give you $5,000 in GCP credits for you to play with, for you to test out. $5,000 is sometimes enough to run a whole research project, depending on the workloads you're looking for. So contact us. We're here to help. We do a lot of work with students. We do a lot of work with researchers. We do a lot of free online training. Again, I will double my offer. If you contact me on email or WhatsApp, I will give you free online training to up to 30 researchers in your institute. So do reach out. Before I end, I just wanted to say, a lot of researchers I speak to are worried. Oh, but cloud is tricky. I don't know how much money I need for my grant. What's the budget? Don't worry. We take that trickiness out of it. Talk to us. We'll help you predict your exact spend. And in there is a possibility. We are experimenting with customizing a flat fee pricing for eligible initiatives. So depending on what you're running in cloud, it can be very predictable, and we can give you a flat fee price upfront, regardless of how many CPUs, memory, disk, and IO you use. So with that, I'd like to really thank everyone for attending. Good luck for the rest of the day. It was a pleasure being here.
Thank you, Basil. So guys, excellent offer on the floor, and I'm sure the researchers will be excited about the offer. So Basil, one question. What if they missed it and they came later and they want to...
Melwin, I cannot refuse a request. So even if they missed it live, I know this is recorded and will be shared with all attendees. So do reach out, and I'm sure I can convince. This is a proof point, and I'm trying to make a point here with my marketing team within Google. So even if you watch it on the recording, do reach out, and I will continue to extend the 5K offer for the next 30 days after this event.
Wow, that's an excellent offer. Thank you very much, Basil, for your support and for Google Cloud support. And see you around then.
Thank you very much. Have a great day.
Thank you, sir. Bye-bye.